Hello everyone, this is Mrs. Talipman. Today's lesson is on the rules for significant figures. On this lesson, I will explain the rules used to determine the number of significant figures in a quantity. There are 4 basic rules we need to follow. The first rule states that all non-zero numbers are significant, meaning they count as significant figures. For example, the first quantity we have here is 613. It has 3 significant figures because all 3 numbers count. They are all non-zero numbers. The second quantity we have here is 123,456. Again, all digits count as significant because none of them are zeros. So this would have 6 significant figures. Let's try to come up with another example. Let's say that we have the number 3,678. Since we have 4 digits here, they all count again because none of them are zeros. If we had a 0, it would not count. So this one has 4 significant figures. The second rule we have to follow states that zeros located between non-zero digits are considered significant, meaning that they do count. Here we have 3 examples. The first example is 5,004. The zeros in between the non-zero numbers count according to this rule. Let's take a look at one more example using the second rule for significant figures. Let's say we have the number 3,045. The first number 3 will count because according to rule 1, it's a non-zero number. Number 4 will be the same and number 5 will be the same. This 0 would also count because it's in between 2 non-zero numbers. So we would have to count in all 4, and we can say that this quantity 3045 has 4 sig figs or significant figures. The third rule to use for significant figures states that trailing zeros are significant only if the number contains a decimal point. Otherwise, they are insignificant. They don't count. What this means is that if there's no decimal anywhere on the quantity you're working with, the zeros at the end or the trailing zeros do not count. If there is a decimal somewhere on the quantity, then the trailing zeros or zeros at the end do count. The first example we have here is 5.640. The 5 counts according to rule number 1. The 6 and the 4 also count according to rule number 1. The number in question is the last 0. This last 0 would also count because we have a decimal, and according to the third rule, if there's a decimal, the zeros at the end do count. That's why we say that this quantity has 4 significant figures. The next quantity we have is 120,000 with a decimal at the end. Because there's a decimal at the end, those 4 zeros have to count. And we already know that the first 2 numbers are non-zeros, therefore they count. So we have here 6 significant figures. The last example we have is 120,000, just as the previous one, but without the decimal. We have to count the 1, we have to count the 2, according to rule number 1. The last 4 zeros are not counted because there's no decimal on this quantity. And the rule says that if the trailing zeros don't have a decimal anywhere on the number, they do not count. So for this quantity, we can say that 120,000 has 2 significant figures. Let's think of another example. Let's say we have the number 120,340. Okay, so let's look at all the rules we've used so far. The first rule says that all non-zero numbers must count. So we have 1 here, 1 here, 1 here, and 1 here. The second rule says that zeros in between non-zero numbers must count. So this 0 right here counts because it's in between the 2 and the 3. The third rule says that trailing zeros or zeros at the end are only significant if there's a decimal point. There is no decimal point on this quantity. Therefore, we can say that this 0 does not count. So we have 1, 2, 3, 4, 5. So we have a total of 5 significant figures in this example. The last rule we have to follow is a rule that states zeros to the left of the first non-zero digit are insignificant, meaning they don't count. They are only placeholders. Zeros to the left mean the ones at the very beginning. So let's look at the first example. We have here 0.000456. All these zeros right here do not count because they're to the left and they're before the first non-zero number, which happens to be 4. So we can only count the non-zero numbers in this case. So we count the 4, the 5, and the 6. That is why we say we have 3 significant figures. The second example we have here, we have 0.052. The first 2 zeros do not count because, again, they are to the left of the first non-zero number, which is the 5. We can count the 5, we can count the 2 only. Therefore, we have 2 significant figures. The last example has 0 points and all these zeros before the first 5, which is a non-zero number, and then the 2. So these two here, the 5 and the 2, would count as being significant. All these other zeros do not count because they are to the left of the first non-zero number, as the rule states. Now that we have gone over all 4 rules, let's see if we can apply them to these examples. The first example we have here is 1.234. Since all of these digits are non-zero numbers, according to rule number 1, they all have to count. So we can say that on this quantity we have 4 significant figures. The second example we have here is 23,457.2. Again, all these numbers are non-zero numbers, therefore they all count as being significant. So we have 6 significant figures in this case. The next example we have is 0.00357. According to the last rule, zeros in front of the first non-zero numbers do not count. So we would only say that we have 3 significant figures, the 3, the 5, and the 7, because according to rule number 1, non-zero numbers always count. The next example, is 1,305.7. We already know that the 1 counts, the 3 counts, the 5, and the 7 according to rule number 1. Then we can say that rule number 2 states zeros in between non-zero numbers are also significant. Therefore, this 0 counts as well. Therefore, we have 5 significant figures on that quantity. The next example is 305. Same as the previous one, the 0 in between the non-zero number counts. Therefore, all 3 count, and we have 3 significant figures. The next example is 7,500. Of course, the 7 and the 5 count. The last 2 do not count because they are zeros at the end or trailing zeros where there's no decimal anywhere on the number. Therefore, they do not count. So here we have 2 significant figures. The last example we have here is 1.00735. Then we think about rule number 1 that says all non-zero numbers count. And then we can think about the second rule that says that zeros in between non-zero numbers count. Therefore, these 2 zeros count. So our answer would be 6 significant figures. Well, to recap, we have 4 rules that we have to consider when we are figuring out how many significant figures we have in each quantity. The first rule states that all non-zero numbers are significant, meaning that 1, 2, 3, 4, 5, 6, 7, 8, and 9 are considered significant numbers. The second rule says that zeros located between non-zero digits are significant. So zeros that are in between non-zeros, like this one right here or the 305 here, they also count as being significant. The third rule says that trailing zeros or zeros at the end are only considered significant if there's a decimal number somewhere, a decimal point somewhere in the number, excuse me. So, for example, on this last question here, on this last practice problem here, if we had a 0 at the end, then that 0 would count according to our third rule, because zeros at the end count if there's a decimal somewhere in the number. So then that would make it 7 significant figures in this quantity. The last rule states that zeros to the left of the first non-zero digit are insignificant, or they do not count because they're only placeholders. The example would be this one right here. The zeros in front of this 3 do not count. They're in front of the first non-zero number. So I know that's a lot of information, but we will be practicing the 4 rules throughout the rest of the year as we use significant figures when we are collecting data and when we are doing calculations in the lab. For the next part of this activity, I would like you to do these 5 problems for homework. Just write them down in your notebook and write down how many significant figures each of these 5 quantities have, and then we will go over these answers tomorrow during bell work. Thank you.